Hello there, this is Mr. Beanmat and welcome to our new lesson. In our today's video, I want to introduce to you the idea of geometric sequence. Our objectives. In this video, viewers are expected to illustrate geometric sequence, differentiate geometric sequence from an arithmetic sequence, and determine nth term of a geometric sequence. On my previous video, I discussed about arithmetic sequence and how to get the common difference. If you haven't watched it yet, please check out the link on the description box. So for today, we are going to discuss about geometric sequence and how to get the common ratio and nth term. Now let's define geometric sequence. Geometric sequence, which is also known as geometric progression, is a sequence wherein succeeding terms are obtained by multiplying a fixed number called the common ratio. So malalaman lang natin na geometric ang sequence kapag may common ratio sila. So to find the next term in a GS, we use the formula a sub n is equal to a sub 1 times r raised to quantity n minus 1, where a sub n is equal to nth term, a sub 1 is equal to first term, n is equal to number of terms in the geometric sequence, and r is equal to common ratio. Now let's try to answer the following activity and tell whether the sequences are geometric or not. Let's get started. For number 1, the given terms are 12, 6, 3, 1.5, and so on. Is it GS or not? First, let's check if the given sequence has a common ratio. How to find the common ratio? All we have to do is to divide the second number to the first number. So let's try 6 divided by 12 is equal to 1/2. 3 divided by 6 is equal to 1/2. And 1.5 divided by 3 is equal to 1/2. Notice all of them has a common ratio of 1/2. So therefore, the answer for number 1 is GS. For number 2, we have 2, 3, 5, 6, 8, and so on. Now, let's figure out if they have common ratio by dividing the second term to the first term. 3 divided by 2 is equal to 1.5. 5 divided by 3 is equal to 1.6. 6 divided by 5 is equal to 1.2. And 8 divided by 6 is equal to 1.3. So as a result, the sequence has different ratios. So therefore, the answer is not GS. For number 3, we have 10, 20, 40, 80, and so on. Is it GS or not? Let's find out. 20 divided by 10 is 2, 40 divided by 20 is 2, and 80 divided by 40 is also 2. So therefore, the answer is GS because it has common ratio of 2. For number 4, the given are negative 2.2, negative 3.3, negative 4.4, negative 5.5, and so on. Let's figure out if they have common ratio. Negative 3.3 divided by negative 2.2 is equal to 1.5. Negative 4.4 divided by negative 3.3 is equal to 1.3. And negative 5.5 divided by negative 4.4 is equal to 1.25. So for number 4, the answer is not GS because the sequence has different ratios. And as you can see, this is an example of arithmetic sequence because the sequence has common difference of 1.1. For number 5, the given are 9, negative 9, 9, negative 9, and so on. Obviously, lahat sila will result to negative 1. Negative 9 divided by 9 is negative 1. 9 divided by negative 9 is negative 1. And negative 9 divided by 9 is equal to negative 1. Therefore, the answer is GS because the sequence has common ratio of -1. Now, let's try to answer the next slides. You can stop or pause the video at each slide and watch it again if you need to. Is it GS or not? Yes, it is not a GS because this is an arithmetic sequence. GS or not? Yes, it is GS because it has a ratio of 1/5. GS or not? Yes, it is GS because it has a ratio of -4. GS or not? Not a GS because it has no common ratio. GS or not? It is GS because it has a ratio of 1. Now, let's discuss how to find the ratio in the geometric sequence. To find the R or the ratio in geometric sequence, just divide the second term with the first term, then the third with the second, and so on. Now, let's have an example. Find the R in the sequence 3, 6, 12, 24, and so on, where a sub 1 is equal to 3, a sub 2 is equal to 6, a sub 3 is equal to 12, and a sub 4 is equal to 24. So as I've mentioned earlier, to find the ratio, we will divide the second term with the first term, then the third with the second, and so on. First, let's start with 3 and 6. So R is equal to a sub 2 divided by a sub 1, which is equal to 6 divided by 3, and the answer is 2. Second, we'll divide the third term with the second. R is equal to a sub 3 divided by a sub 2 equals to 12 divided by 6, and the answer is 2. Lastly, we'll divide that fourth term with the third term. R is equal to a sub 4 divided by a sub 3 is equal to 24 divided by 12 is equal to 2. So therefore, the sequence has a common ratio of 2. Now, let's try to answer the following examples on how to get the common ratio and the next three terms in a geometric sequence. Let's get started. For number 1, we have 2, 4, 8, and 16. So for us to get the next three terms, we have to solve first the common ratio of the sequence by dividing the second term to the first, the third to the second, and the fourth to the third. So 4 divided by 2 is equal to 2, 8 divided by 4 is equal to 2, and 16 divided by 8 is equal to 2. So therefore, the common ratio is 2. Now, we'll multiply the ratio to the succeeding terms for us to get the next three terms. So, we'll start on multiplying 2 to 16 terms. So 16 times 2 is equal to 32, 32 times 2 is equal to 64, and 64 times 2 is equal to 128. Therefore, our next three terms are 32, 64, and 128. Now let's try number 2. Negative 6 divided by negative 2 is equal to 3. Negative 18 divided by negative 6 is equal to 3. Negative 54 divided by negative 18 is equal to 3. So the common ratio is 3. Now let's start to multiply 3 to the succeeding terms. Negative 54 times 3 is equal to negative 162. Negative 162 times 3 is equal to negative 486, and negative 486 times 3 is equal to negative 1458. Therefore, the next three terms in the geometric sequence are negative 162, negative 486, and negative 1,458. Now, let's try number 3. 0.4 divided by 0.1 is equal to 4. 1.6 divided by 0.4 is equal to 4. 6.4 divided by 1.6 is equal to 4. So the sequence has a common ratio of 4. Now, let's start to multiply 4 to the succeeding terms. 6.4 times 4 is equal to 25.6. 25.6 times 4 is equal to 102.4, and 102.4 times 4 is equal to 409.6. Therefore, the next three terms in the geometric sequence are 25.6, 102.4, and 409.6. Example number 4. 0.9 divided by 0.9 is equal to 10. 9 divided by 0.9 is equal to 10. 90 divided by 9 is equal to 10. So the sequence has a common ratio of 10. Now, let's start to multiply 10 to the succeeding terms. 90 times 10 is equal to 900. 900 times 10 is equal to 9,000. And 9,000 times 10 is equal to 90,000. Therefore, the next three terms in the geometric sequence are 900, 9,000, and 90,000. For number 5, 49 divided by 343 is equal to 1 over 7. 7 divided by 49 is equal to 1 over 7. 1 divided by 7 is equal to 1 over 7. So the sequence has a common ratio of 1 over 7. Now multiply 1 over 7 to the succeeding terms. 1 times 1 over 7 is equal to 1 over 7. 1 over 7 times 1 over 7 is equal to 1 over 49. And 1 over 49 times 1 over 7 is equal to 1 over 343. Therefore, the next three terms in the geometric sequence are 1 over 7, 1 over 49, and 1 over 343. Now, let's discuss how to find the end term in a geometric sequence. But how we will find the end term in a geometric sequence? To find the end term, we use the formula a sub n is equal to a sub 1 times r raised to quantity n minus 1. Let's have an example. Find the sixth term of the sequence 3, 9, 27, 81, and so on. Using the formula, we'll substitute the terms where a sub n is equal to a sub 6, a sub 1 is equal to 3, and n is equal to 6. And because wala pa tayong r, we'll solve the first common ratio of the sequence. So we'll do same process. Divide the second term to the first, third to second, and so on. So 9 divided by 3 is equal to 3. 27 divided by 9 is equal to 3, and 81 divided by 27 is also equal to 3. So our common ratio is 3. Now let's substitute the terms to our given formula. A sub 6 is equal to 3 times 3 times raised to quantity 6 minus 1. A sub 6 is equal to 3 times 3 raised to quantity 5. A sub 6 is equal to 3 times 243. And the final answer is a sub 6 equals to 729. Therefore, 729 is the sixth term in the geometric sequence. Now, let's try to answer the following examples. Let's go! Number 1. Find the seventh term of the sequence 0.0008, 0.008, 0.08, 0.8, and so on. A sub n is equal to a sub 7, a sub 1 is equal to 0.0008, and n is equal to 7. Now, let's find the common ratio. 0.008 divided by 0.0008 is equal to 10. 0.08 divided by 0.008 is equal to 10. And 0.8 divided by 0.08 is equal to 10. So, the common ratio is 10. Now, let's substitute the terms to our given formula. A sub 7 is equal to 0.0008 times 10 times raised to quantity 7 minus 1. Subtract 7 to 1 is equal to 6. Then multiply 10. 6 times and the answer is 1 million. Now, 0.0008 times 1 million is equal to 800. So therefore, 800 is the 7th term in the geometric sequence. Find the 10th term of the sequence 1, 2, 4, 8, and so on. A sub n is equal to a sub 10, a sub 1 is equal to 1, and n is equal to 10. Now, let's find the common ratio. 2 divided by 1 is equal to 2, 4 divided by 2 is equal to 2, and 8 divided by 4 is equal to 2. So the common ratio is 2. Now, let's substitute the terms to our given formula. A sub 10 is equal to 1 times 2 times raised to quantity 10 minus 1. Subtract 10 to 1 is equal to 9. Then multiply 2 9 times and the answer is 512. Now, 1 times 512 is equal to 512. So therefore, 512 is the 10th term in the geometric sequence. Number 3. What is the 8th term of the sequence 1 over 36, 1 over 6, 1, 6, and so on? A sub n is equal to a sub 8, a sub 1 is equal to 1 over 36, and n is equal to 8. Now, let's find the common ratio. 1 over 6 divided by 1 over 36 is equal to 6. 1 divided by 1 over 6 is equal to 6. And 6 divided by 1 is equal to 6. So the common ratio is 6. Now, let's substitute the terms to our given formula. A sub 8 is equal to 1 over 36 times 6 times raised to quantity 8 minus 1. Subtract 8 to 1 is equal to 7. Then multiply 6 7 times and the answer is 279,936. Now, 1 over 36 times 279,936 is equal to 7,776. So therefore, 7,776 is the 8th term in the geometric sequence. Number 4. What is the 9th term of the sequence 3, 6, 12, 24, and so on? Where a sub n is equal to a sub 9, a sub 1 is equal to 3, and n is equal to 9. Now, let's find the common ratio. 6 divided by 3 is equal to 2, 12 divided by 6 is equal to 2, and 24 divided by 12 is equal to 2. So the common ratio is 2. Now substitute the terms to the formula. A sub 9 is equal to 3 times 2 times raised to quantity 9 minus 1. Subtract 9 to 1 is equal to 8. Then multiply 2 8 times and the answer is 256. Now 3 times 256 is equal to 768. So therefore, the 9th term in the geometric sequence is 768. One more to go and we're almost done. Finally, find the 12th term in the sequence 3, negative 6, 12, negative 24, and so on, where a sub n is equal to a sub 12, a sub 1 is equal to 3, and n is equal to 12. Let's find the common ratio. Negative 6 divided by 3 is equal to negative 2. 12 divided by negative 6 is equal to negative 2. And negative 24 divided by 12 is equal to negative 2. So our common ratio is negative 2. Let's substitute the terms. A sub 12 is equal to 3 times negative 2 times raised to quantity 12 minus 1. Subtract 12 to 1 is equal to 11. Then multiply negative 2. 11 times, and the answer is negative 2048. Now 3 times negative 2048 is equal to negative 6144. Therefore, the 12th term in the geometric sequence is negative 6144. Please like and subscribe to my channel, and don't forget to click on the bell icon to get new video updates. Thank you for watching!